Hello and welcome to Science Never Stops. I'm your host, Joseph Vick with the U.S. Space and Rocket Center, here today with NASA Marshall Space Flight Center guest, NASA plasma physicist, Dr. Dennis Gallagher. Welcome, Dr. Gallagher, to Science Never Stops.
Thank you very much.
So let's go ahead and get started with some questions here for our viewers. Could you please explain to our viewers what exactly a space plasma physicist studies and tell us about some current NASA projects you're working on?
Well, a space plasma physicist works to understand how regular matter behaves in space. That could be around the Earth, it could be around a distant star, or on the sun. I'm studying images of, right now, the project I'm working on is to study images of the electrically charged gas, helium gas, surrounding the Earth. The images were obtained from the NASA science mission called IMAGE. The purpose of this study is really test and develop a new technique for analyzing the images. If it works, I hope it does, scientists can use it to better understand how this low energy part of the electrically charged gas around the Earth behaves and interacts with Earth's upper atmosphere.
Nice. And with those things that you're currently working on, you had to have some sort of educational background. Can you tell us about your educational background and how it helped you obtain your current NASA position?
Well, so I did my undergraduate work at the University of Iowa State University. I grew up in Iowa. My doctoral research, a master's and doctorate in physics, all of them in physics at the University of Iowa. So, and typically researchers will either have a master's or a doctorate. You then spend maybe two to 4 years in a postdoctoral position where you get out and really start to explore on your own more so what kind of research that you would be doing and how to do it. The way that you get a position is initially postdoctoral positions based on your recommendations from your advisor, from people that you've worked with, presumably published in a little bit in graduate school. And that's how you get an initial position. After that, your position comes from your performance. Are you doing research? Are you publishing? Are you writing proposals to get funding to do that? Are you going out into the community and giving talks at conferences or at different institutions?
Growing up in Iowa, was there a certain class, extravehicular activity, extracurricular, not vehicular, extracurricular,
I was hoping,
mentor or experience that helped to shape your career path?
Well, there are a lot of people that had an awful lot to do with how I progressed, both senior people that I had a lot of respect for, even my friends, graduate student friends, because of what they found actually led me to the University of Iowa. Maybe the first influence, mentors, were two teachers at North High School in Des Moines, Iowa, where I went to high school. They really got me motivated and interested in science and technology. Mr. Bly was a math teacher who started a computer club in 1967. There weren't very many computers then, certainly not in the classroom. We went to the county IBM 1401 computer every Saturday to learn how to program in Fortran. It was amazing, in spite of the punch cards. I can't do my research without computers today. I use the skills he taught us every day in what I do. Mr. Franz, the physics teacher at North, he really showed me things that I hadn't seen before. He shared physical science, and it made sense to me. Weirdly, like I knew it before I knew it. Somehow I hope all kids have the opportunity to find that kind of experience.
with your academic career, what would you say would be your biggest academic or career setback, and what did you do to overcome it?
There are a lot of things that happen. One of the first setbacks I had was when I defended my master's thesis. I was a fairly new graduate student still. This was at the end of the first 2 years. At Iowa, they, at least then, had you do a master's before you did a doctorate. And during my thesis defense, I was asked what the density was of the solar wind near Earth. Totally blindsided me. It might not seem like, a serious kind of thing, well, I didn't know that. It wasn't part of my thesis research, my master's. But the question was asked by Professor James Van Allen of the Van Allen radiation belts. And I felt pretty bad that I didn't know the answer to that question. What I had done in working on my master's was to focus really narrowly on what I was doing for the thesis. I wasn't looking at space physics. I wasn't, looking beyond. My study had to do with a thing called auroral kilometric radiation. It's strongly influenced by interaction with the solar wind. That's the bigger context. I should have been looking at the bigger context. And I learned that lesson. And I've been on multiple thesis committees since. I've mentored a lot of students over the years. And every single time I tell them that you really need to pay attention to the context that the thing you're working on fits. How does it fit? What's its significance? And you really can't do science successfully unless you do that.
And not to put you on the spot, but what is the answer to that question?
It's about 4 or 5 particles per cubic centimeter on a nice calm day. And with the wind blowing at a modest 400 kilometers per second, or about 1 million miles an hour. That's a nice calm day in the solar wind.
So who would you say is your favorite scientist and why?
Favorite scientist? A lot of people, I respect a lot of scientists that I've worked with and known. So I'm going to go with the first again. That was probably Mr. Wizard. He was on TV for kids and gave all sorts of demonstrations, and it was amazing.
I remember he did an experiment. That fascinated me. It was, I think, the first time I ever saw him, where he took a sewing needle, a straw, and an old LP album and set it up and spun it around, and you could hear it. That just fascinated me as a kid. So,
yeah, the experiment I have in my head was when he took a jerry can, a thin metal gas can for a car, and connected it to a pump, and just crushed it. Just took all the air out, and the air around just crushed that can. It was very impressive. I get to do that today when I do experiments with a vacuum system for kids and adults.
Nice. Well, do you happen to have any special abilities, talents, or hobbies that might surprise people that you'd like to share?
Surprise people? Well, most people know, that I work with, would know that I like to hike. I like to bicycle and play volleyball. Probably the most oddball thing for me for being a scientist is that I used to make pieces of art using plexiglass and wire.
Cool.
I went through phases, okay? In college, I went through phases. There was the can't wire anything up with 110 without blowing it up phase. And there was the take everything apart and not be able to put it back together again phase. I also had a phase where I was making digital clocks. That started in '71 with a clock I made for my wife. But kept getting fancier and fancier and using and emphasizing not the clock so much as the case for the clock. And I was using plexiglass, and I had a lot of wire. And one time I was just playing with a wire, stranded wire, and I made a small hand figure with a wire, and one thing led to another, and I started making other sorts of pieces. I was even commissioned once.
Way cool. Well, do you happen to have a personal motto or advice to pass along to the next NASA career generation?
The kind of thing that I think is important isn't something that's restricted to NASA scientists or NASA employees. I think it's true for everybody. That is that if you know you're right, you're probably wrong.
Okay.
If you don't go into a conversation, and I don't care what it is, the day of the week, that the sun will rise the next day, think about it. The sun doesn't have to rise tomorrow. If we got hit by a big enough rock, it wouldn't. Meaning an asteroid, really big. So there's always something. There's always something you don't know. There's always some caveat and some different experience that other people have. You need to listen, and you'll learn a lot more than being adamant about what you think you know.
That's great advice. Well, is there anything else you'd like to add or say?
Oh, just that, I've had a life of learning. What education did I have? Well, it's still going on. I got my degree in '82, doctorate, and in '74, when I graduated college, the chair of the department said that we had been trained to solve problems. We hadn't been trained to solve a problem anybody cared to pay us for, but that we'd been trained to solve problems. Go out and figure out what problems you want to solve, learn what you got to for that, and go solve problems. And everybody should learn how to solve problems, how to organize their thoughts, how to recognize what's not needed, what is needed, what's wrong, what's right, and how to approach life.
Going into life with the idea or mindset of being a problem solver is really good advice right now. Well, thank you, Dr. Gallagher, for joining us today. And for all our guests that are tuning in, remember, science never stops.